Hi coders, welcome to this new course on C++ programming. My name is Prashant Chaudhary. I welcome you all to this course. Many of you have requested to create a video on C++ programming. So here it is. So there are total 10 modules in this series and this is module 1. We will be subsequently uploading future modules, and once all the modules are uploaded, we'll create a single compilation video of all the modules. So let us begin. We'll start with the basics first. So C++ is a middle level language. It was developed by John Stroustrup starting in 1979 at Bell Labs. C++ runs on Windows, Mac OS and different Unix distributions. So it doesn't matter which operating system you're using, you will obviously find a suitable compiler. GCC is one of the most common compiler. Few colleges are using Turbo C, a compiler by Boland, that is also fine. There could be slight differences between the programs, but that is still okay. Most important thing is you to understand the concepts. So who can learn this course? Anyone can learn this course. And when we are learning this, knowledge of C languages is not needed, but it is good to have, because I won't be explaining programming logic or how the programs are executed in this course. So all the students, professionals can take use of this course, and what to expect from this course and what not. You will not learn this language in a day, so have patience to learn. It could take some time. While saying that, I can assure you that learning C++ is not hard, but it needs time and practice. So it will build foundation of object-oriented programming concepts, and if you want to learn programming logic, you can do that separately by watching our video on C programming, where we have covered 101 programs. I'll be giving link to that video in the description box. Also, I'll add it in the eye icon at the top. So when you're learning C++, which compilers to use? On Mac OS operating system, you can use either Xcode or GCC from terminal. JN use GCC compiler, and on Windows you can either use CodeBlocks or Turbo C++ compiler from Boland. In case you are finding trouble in setting up the compilers, then you can use online resources. I can suggest you two websites. One is ide1.com and other one is onlinegtp.com. So these websites have online editor. You can write your programs over there, and you can select the compiler and click on the run button. It's fairly easy to use, so you can give it a try. So what are we going to cover? So basics like data types, constant, variables, we are just going to touch those at the very basic level. If else, while loop, for loops, function pointers, strings and arrays. So this is something that we have already covered in the previous video. We have created a video wherein only theory is there. So I'll explain about that in a bit, but majorly what we are going to cover in this video is object-oriented programming. So we'll be concentrating our study on classes, objects, inheritance, overloading, polymorphism, abstraction, encapsulation, and interfaces. So here is your first C++ program. So #include iostream is the header file that we required on our C++ programs. Again, using namespace std. It could be optional on Turbo C compiler. So these files are required basically to perform input-output operations and execution of your program. These double slash lines are nothing but a comment. Similarly, this line is a comment. As we all know, semicolon is something that separates all the instructions. So these are two semicolons. So this is my main function. It has two instructions in it. Notice that it main being a function, it has a return type int. So at the end of the function, I have returned 0, which is an integer. So this statement, cout less than, in the double quotes, I've written www.kodegod.com. What this statement does is it will print www.kodegod.com on the output screen. So cout is used to print output on the output screen. So we'll be talking about this operator in great detail when we learn about operator overloading in the subsequent slides. The code lines can be like printing and returning values. Similarly, there could be arithmetic instructions like this, wherein I have given two examples: a equal to b plus 10, semicolon. On the next line, c equal to a minus 10, semicolon. We usually write our instructions one below the other. However, for compiler, writing statements like this is also okay. For compiler, these are two different statements. So semicolon is something that is acting as a separator. So because of this semicolon, compiler will get to know that this instruction ends here and this is the second instruction. So let us touch more on how we can add comments in the C++. So this is one example and this is the second example. So double slash is used for single line comment and slash star and star slash are used for adding multi-line comments. You can add single line comments after semicolons also. So this whole part will be neglected by the compiler. So we use comments for our understanding how to make code more readable and more understandable. C++ has added few more new keywords in comparison to C language. So these are all the keywords that are supported in C++. So you can notice these are new keywords. So private, protected and public, these are a few common keywords that will be using more frequently in C++. Other than that, you can check the char, else, if or go to. These are few common keywords which we have used in C language more often. Now let me talk more about data types. So there are two types. We have primitive like bool, char, int, float, double, void and wchar_t, which is a void character, and you already know about all these primitive data types. Then we have something called as modifier. Signed, unsigned, short and long. These are modifiers. So these modifiers we can attach with the primitive data types. So for example, we can have signed int or you can have unsigned int. So these are the set of data types which are available in C++ in conjunction with the modifiers. So this is the modifier and this is our primitive data type. So in the second column we have the bit width required for the type. So for example, int will require 4 bytes and because of the 4 bytes it can store number from this given range. So we don't need to memorize this table, but this is just to have a general understanding how much byte size a particular data type will require. For example, float will require 4 bytes and so on. We can also do the declaration using typedef keyword. So syntax for that is typedef keyword, then you add your type and the name of that particular variable. So for example, I am writing typedef int wheels. So what is happening over here is wheels become a custom data types of type int. So instead of writing int car wheels, I can now write wheels space car wheels, and then I can initialize car_wheels is equal to 4. I guess there's a small mistake here. I forgot an underscore over here. So after we write this statement, so int wheels var is almost similar to writing wheels underscore var. So technically these two statements are same because wheels is of type int because of this typedef statement. Then we have enumerated types. So syntax of declaring an enumerated data types is enum, then your enumeration name, then in the curly braces you write list of the enumerated names, and you can inline create variable list of the declared enumeration. So for example, I am creating one enumerated type as gender and I am setting two values as female and male. Notice here when I don't initialize anything, so default values are zeros and ones. So it starts with 0. So enumerated value female is 0 and enumerated value of male is 1. So G1 is a variable of enumerated type gender. Alternately, I can create another variable like gender G2. Then we have G1 equal to Gmail. Then we have G1 equal to female. So I am setting value female, which is 0 into variable G1. Similarly, I am writing G2 equal to male. So I am setting 1 as the value inside of G2. Another example, I am creating another enumerator type as fruits. So when I don't declare values for all the variables, compiler takes reference of one value 4. Hence, apple gets assigned value as 3 and orange gets value assigned as 5. Now let us talk about variables and scope of the variable. So we can declare variables with the data type name and then variable list. So this is exactly similar to what we have done in C programming language. So int ABC, so ABC becomes 3 integer variable. Then char C1 equal to inside of single quotes capital C. So ASCII value of capital C gets assigned to C1, or alternatively I can write C2 equal to 67. In that case also ASCII value is stored into character C2. Then I can have a float variable initialized to 3.142. Name of that variable is pi, and then another variable area which I am not initializing. Another variable is double D. So D is the variable of type double. Now let us talk about scope of variables. Consider this as a program. When I write int x equal to 10, so here x is outside of main function, so it becomes a global variable. So x becomes available across all the functions. Similarly, inside of main function, when I am writing x equal to 20, notice I have initialized x here. So this x is local to the function main. However, this variable x is global to our program. So when I write cout x, so compiler will give preference to the local version first. So output of this program is 20. We already seen that we can use type modifiers. So signed, unsigned, long and short, these being my modifiers, I can use it like this, short int x. So x is signed short integer and then short unsigned int y. Here y is an unsigned short integer. Now let us talk about storage classes in C++. So by default, auto is the type assigned to all the local variables. So when I write int x, so variable x has storage class as auto. And then we have register as storage class. So whenever we require some variables which need faster access, so in that case I can use a register as storage class in front of data type name. For example, register int x equal to 10. So this variable x will be allocated memory inside of a register instead of RAM. Then we have static. So static exists during lifetime of the program, maintains value across all the functions. So whenever you define a variable of storage class type static, so that variable will maintain its value throughout the program and across all the functions. Then we have extern. There could be a case wherein your program is not a single file but it is spread across multiple files. So in that case you can use extern variable, and that extern variable can be referred from any other file. And the final type is mutable. It allows member of an object to override const member function. So this is something that this is something that I can explain later when we talk about const member function. Here is the example. Int x and auto int x is almost the same statement because auto is the default storage class. And here's the other example, register int index. So index variable will get allocated memory inside of register memory instead of RAM, because we have specified that storage class for this index variable is register. We'll take two examples on static and extern. As we discussed earlier, static exists during lifetime of the program and maintains its value across function calls. So in the example, I have static int I equal to 3. Then I have forward definition. Then I have this function called as my function. So it is just printing value of I and incrementing it. And then inside of main function I am just reprinting the value and incrementing it. Then I'm making a call to my function, and one more time I'm going to print the value of I and increment it. So let us see what is going to happen in the execution. So very initially what is going to happen, compiler is going to declare a variable I and allocate it memory into RAM and initialize it with the value 3. So I is initialized to 3. Here 3 will be printed and then value will be incremented to 4. So these are the // I'm just writing it as a comment. Then we are making a call to function my function. So because it is a static variable, the current value, that is 4, it will be printed over here and value will be incremented to 5 because of this statement. Then compiler will move back to this position because execution of this statement is completed, and we are just printing value of I again, so which is 5, and value of I will be incremented to 6, and then your program will end. So you've seen here that value of I is maintained across all the functions. So in few scenarios it makes sense to use static variable, but not always. Then we have storage class called as extern. It makes variables accessible across program files. So in this example we have these two C++ files, storage underscore classes.cpp and extern.cpp. So in the first file I have declared a variable. This is a forward declaration of my function print underscore extend, and then in the main function I am just initializing value of I to 10 and I am calling the function print underscore extend. So this print underscore extend function is declared in this other file. So writing this statement extend int I am referring to this variable and I'm declaring my function over here print underscore extend. I'm just printing current value of I. So output of this program is nothing but 10. So extend variables are used where you initialize few variables outside of main function and you require those functions to be used in some other files as well. So here is the command on in case you're using Mac OS and you're using GCC compiler, then you can use this command. You can write G++, your C++ file name and this second file name, because this program consists of two C++ files, and using -o I am telling compiler to create my output file as extern. In case there are no errors in the program, it will create executable file as extern, and then you can execute your program using this command. This is how you can use extend keyword. Now before I end this video, I want to reiterate that a few concepts like operators, decision making, wherein we have if else, nested if else, switch, and then we have loops, while, do while, and for loop. Apart from that, we also have function array, strings, pointers, file input output, structures, pointers. So these all concepts we have covered in C programming video. So what I have done now, I have created a separate video wherein only theory is explained again. What you can do is you can watch that video. Complete explanations and theory about these topics you can find in the I icon here. So before we jump onto the other parts of C++, I strongly suggest you to go through this video, just revise your theory one more time, so it would be quite helpful. So in the next module we will check object oriented programming and its concepts. So stay tuned for that video. I hope you enjoyed this video. If you like this video, I will request you to share this video with your friends. Subscribe to this channel if you haven't. Hit the bell icon also, so whenever we upload the subsequent modules and other videos, you get the notification. Thank you, and I will see you in the next video. Enjoy.